Okay, thanks for tuning into our next lesson, 1.2. So we're going to be talking about segments here and using some algebra to solve for some missing variables too. So whenever you see this new reason little picture here, that means that this term, it could be a theorem, it could be a postulate, it could be just a definition. Those appear, I have magnets in my classroom. And there's one magnet that has segment addition postulate on it. And when we do activities in class or when I'm trying to do a proof with you, I'm going to use those magnets, one, to help with vocab, but two, to actually organize a proof. And that's why it says reason, is because we do statement and reason proofs. So we'll be able to pick up, move these around, play with them, try to decide how to prove things in class. So that's what the symbol means. So this is a very important thing that you ought to know the definition of. So perhaps it's the most important thing in the entirety of the notes here. So let's pay attention here. So if we have 3 points in a line, that's what this says here, that these points are in a straight line, and B is in the middle, then AB plus BC is AC. It's called the segment addition postulate, meaning that if you have a part and you add a part to it, you get the whole. So that's like the oversimplified way of saying it, but you can add bits of segments together. And one thing to note is we see here we're talking about a line segment, and then you see here where it doesn't have the line segment. That was intentional. They're two different things. So there's a difference between AB and line segment AB. Okay? This is a length, like 7. It's actually like equal to a number, whereas line segment AB is an object. Okay? It's like a geometric thing, right? It's a line segment. So when we refer to the length, we use just AB. But when we refer to it as an object, as geometric thing, we use the line segment symbol. So try and pay attention as we go through that and see if you can get it down. Okay. So it says if EG is 59, what are EF and FG? Okay. Well, all we really know is that we can take EF plus FG. We know by the segment addition postulate, a proven statement or fact, that this is equal to EG. And we just plug in what we know now. And this is what we do all the time in geometry. So I know that this is equal to 8x minus 14, and I know this is equal to 4x plus 1, and I'm told in the prompt that this is 59. So all the points for this question are pretty much taken up by this point. This is what I want you to be able to do, is pull from a diagram and also recite a fact that we learned as a reason. Because I trust that you guys all know how to do this, and I'm not testing you over the algebra portion. So you'll kind of see me most times just going through this part a little bit quicker. But that's because I'm sure that if you guys study a little bit, you'll be able to keep up with that. Okay? So x is 6. So what does that mean? It really means that this could be, you could plug back in 6 and get the actual distance of this thing. Right? So this is 48 minus 14, and this is 24 plus 1, 25, and 34. So this is equal to EF, and this is equal to FG. So that finishes the problem. I think on the key I may have stopped here. But remember, we need to plug this back in so that we answer the question. Okay? All right, next one. It says our AC and line segment AC and line segment BD Are they congruent? Well, congruent, as you can see here, means that they have the same length. And since we're on a number line, why not just count and see how many spaces A and C are apart? And that would be the length of AC. Okay, so 2, 4, 6, 7. And then the length, the number, not the object, the length from B to D is going to be 1, 3, 5, 7. So yes, we would say that these guys are congruent. But it's kind of the same for segments to just say that this is this. They're saying two different things. One of them is saying is two objects are equal. One of them is saying that their lengths are equal. But for line segments, if their lengths are equal, then the objects are congruent. You know, they're the same. So these statements, I mean, either one you want to say is fine. However, the question was asking about if the objects are the same. So you want to conclude with saying, yes, the objects are the same. But we said that that's because the lengths are the same. So it kind of all goes in a circle. But they do mean different things. AC versus line segment AC. Okay. This is just a kind of a true and false here. If AB is 9 and BC is 2, then AC is 11. Now, is that true? I mean, there's definitely a case where that is true. If this is 9 and this is 2, like I can definitely picture that. That would be an example where the statement is true. But in math, if you're going to say something's true, it better be true every single time, no matter where those points are. And the truth of it is, the truth of it is that it's actually not always true that it's 11. Because what if we had something like this, where, let's move this guy a little bit closer. This is 2, and this is 9. I think that this distance here, the length would be AC. That looks like a little bit of a shortcut, right? So I would argue that that's probably less than 11. So the statement's false. And down here, we drew a picture. That's enough. We drew a picture, and it's a counter example, which means that it disproves the statement. And you only need one. You only need one. Okay? Two new reasons here, two new key vocab points. These are both definitions. We got a midpoint and we got bisect. So a midpoint, as you probably heard before, is the point that divides a segment in two. So this is the midpoint here. M is a midpoint. Now, bisect is kind of in the same ballpark as midpoint, but bisect is a verb, and it means to split into two. We know that bi means two, and sect is like cutting, right? So a point line array that intersects a segment at its midpoint is said to bisect the segment. So it's pretty common that we have two lines in a picture. So let's say we have the same picture, and there's this line that comes through. Maybe it's called line L. Line L bisects segment AB. Remember, because it's got to bisect an object. So it can't bisect the length. So that's why I put that line over top. And that's when you have these little strokes here. And we're going to talk about, you're going to see pictures, diagrams with those dashes on all the time. It means that they are the same. The same in length. And they're not necessarily the same object, but they're congruent. So you could write that their lengths are the same, but that's also just saying that those line segments themselves, they're congruent to one another. The objects are congruent, the lengths are the same. Okay? So that's bisect, it's just to cut it in half. If you want to remember it that way, that might be easier. But it could be a point, could be a line, could be a ray. It could be another segment, anything that cuts it in half. Okay? So that's bisect. And then one thing that's also true from bisect is that AB is AM plus MB. Okay? So not only are those segments congruent and their lengths are equal, but if you add the two up, you still get AB. Because that's the segment addition postulate. All right, we got 3 more questions here. Just let's talk about these real quick. I don't want to keep you too long. Q is the midpoint. So right when they say that, I can put my marks here. That way I know that PQ is QR. Plug it in. Solve for x. I'm going to subtract 5x and add 7. Okay, I have x, so it's probably time to just plug that in. And you can organize your work however you want, whatever makes sense to you. This makes sense to me to just kind of put it right next to the picture. It's 41, so PQ is 41. I'm going to plug in 8 here as well, and that's 41. QR is 41, which makes sense because there was a midpoint and it cut it into 2 equal parts. And then PR, we know that PR by the segment addition postulate is the 2 parts added together, which in this case is going to be 82. If AD is 29, is C the midpoint of BD? It's a good question. One thing I know is that AD is AB plus BC plus CD. So 29 is equal to 5x minus 10 plus 2x plus x plus 2 plus this. And if we go ahead and combine like terms, I have a 5x, an x, and a minus 2x. It's going to get me down to 4x. And then this is going to be plus 9. 20. Cut it in half. Cut it in quarters. It's 5. Okay. So they want to know if C is the midpoint of BD. So we should probably go back to our picture and just note what these lengths are, because we're talking about this segment here. So if C is going to be the midpoint, it looks like it's going to have to be 7 on both sides. So let's double check, make sure this is going to be 7. And it is. So yes. And this is because BC is equal to CD. 7 is equal to 7. Okay. And then the last one. PB bisects line segment AC at point B. That's what the picture is showing us. And when they say bisect, I know for certain that there actually are dashes here. And those dashes, whenever you make dashes like that, you almost always are going to set up an inequality. An equality, which I'll just go ahead and solve then for x. So it looks like we get 2. And then they want to know what AB is. So AB is 10 minus 3 times 2, which is 4. Okay? All right, that's it. A lot of info here. The 3 reasons are definitely key here. But the other thing you need to remember is this distinction right here. So again, the top, this part, these are objects. line segment AC is congruent. Objects are congruent. These down here are lengths. They're numbers. And numbers are equal to each other. We wouldn't say like 7 is congruent to 7. We would say an object is congruent to another object. Okay, so there's a difference here. We'll do this all year. You'll get used to it. I'm not going to be a huge stickler, but that's the difference. Okay, so it's all intentional.